This is AHL Explains. I'm Anthony Ledford, and today I'll be explaining risk. Today we're going to look at risk, and the basic question we're trying to answer is how to estimate what your losses might be if markets were to move against you. Now our focus will be on two standard measures of portfolio risk that are widely found in both academia and in the industry, and they are value at risk, usually denoted by VAR, and expected shortfall, or ES. And we'll also focus on how these two quantities are related. Now, in order to work out where these things come from, I'm going to go back to thinking about a daily trading system, and I'm going to think about the P&L I'm going to incur over the forthcoming 24 hours, assuming I'm not allowed to change my positions. Now, the P&L I'm going to observe in each market will be the number of contracts I hold in that market, multiplied by the change in price within that market. And because there are multiple markets in the portfolio, I need to add that up over all of those markets in the portfolio. Now this part's easy. This is just how many contracts I hold, and I know that. It's this part here that causes me the headache and means that I've got to do some work. So how are we going to work out what reasonable values are for the forthcoming price changes? Well, we can do that in two ways, and the first of that is to appeal to historical data. And what I mean by that is that I'm going to use the observed price moves I've seen over one-day periods historically as proxies for what I think is going to happen tomorrow. Now, the advantage of that is it's very simple, providing you've got long and good data records. But the disadvantage of it is that you're never going to observe an event that is more extreme than any of those that you've observed in your historical data. And if you want to see more details of this approach, look up bootstrapping. The second way we can do this is by simulation. And what I mean by simulation is building a random number generator that has properties such that it generates numerical values that are good representations for the future price movements. Now, this is something that requires detailed mathematical modelling to get right and do well, and that's its primary disadvantage. But the advantage of this method is that it can generate values that are more extreme than any you've observed in your historical data. So neither of these is ideal. They have advantages, they have disadvantages. If you want to see more information about what underpins the simulation approach, then look up Monte Carlo. So whichever of these I choose, let's suppose that I've generated 10,000 samples of data to allow me to evaluate this expression here, so that I will therefore have 10,000 possible outcomes of what tomorrow's P&L will look like. So let's write that down, 10,000. Now, if I order them from worst outcome, so these will be the losses down here, to the best outcome, which will be the gains up here, then I can put them along this line here in numerical order. So having done that, we can now return to value at risk. And value at risk is usually something that's quoted at a particular level. So let's, for argument's sake, say the 5% level value at risk. Then what I have to do is find the point on this horizontal line which has 5% of the points to the left of it and 95% of the points to the right of it. Well, if there's 10,000 points in my full set, that means I need 500 on the left and 9,500 on the right. And that's what the value at risk at 5% is. It's just the threshold of the loss distribution that splits the outcomes up in the 5%, 95% ratio. So that's value at risk. Let's now think about expected shortfall. If I look at all of the values that are actually more severe in their losses than the value at risk level, and then group those together and take their average, then the number I obtain with that way is the expected shortfall at 5%. So that's the relationship between the expected shortfall and the value at risk. One of them is just the threshold. The other one is the average value of all of the values that are more extreme than that threshold. There is actually a third way of estimating value at risk and expected shortfall, and it's sometimes called the variance or covariance method. The idea is that you estimate the volatility of the whole portfolio and scale that estimated volatility by the corresponding values from the standard normal distribution. Now, any risk monitoring team is going to monitor a whole range of different risk metrics. At the top of their list, you'll probably find the volatility of the portfolio, its value at risk, and its expected shortfall. But after that, there'll be other quantities such as the liquidity of the individual markets that will be monitored. The idea there is you look at the average daily volume that gets transacted in each of your markets and make sure your positions don't become too much of a proportion of those average daily volumes, for the simple reason that if you need to trade out of those positions, it's going to take you a long time to do so if they've become too large. Also monitored will be credit ratings, for example, of the counterparties that are traded with or the custodian banks. And they will also look at risks that aren't so easily quantified, and an example there would be the geopolitical risks, very important in the current world. Okay, that's all I want to say about risk. The next episode, we'll look at signal diversification. Thanks very much.